What we have here is the gel that we're going to use to separate size select our 8 KB Paradigm library on. I'm sure many of you have loaded a Agros gel before. However, the purpose of this video is to show you the slight differences that we use in the Paradigm protocol. At this step, the biggest difference is the size of the well. As is stated in our protocol, we need a approximately 3 centimeter wide comb. What we've done in-house as part of research and development is we've made a wide comb, which is essentially modeled after 3 wells that are taped together. You can see it. Okay. So here's our sample. It has in it our 10x blue juice loading dye as well as our 20% SDS. It's been heated to 65 degrees for 10 minutes and cooled on ice, and we're prepared to load it. The total volume is slightly over 200 microliters. So we'll take a 200 microliter pipetter with a wide bore pipette tip, and we'll load our sample into 3 centimeter wide gel. So here's the majority of our sample. Okay, so I'm just going to find the well and load it in. When you're loading, you want to disperse it across the comb, or across the well, excuse me. Trying to avoid getting as much pipetting out as possible. Okay, now that our sample is loaded, we're going to run this for the 8 KB Paradigm gel. We're going to run it at 85 volts for 4 hours. This is our gel. We've just finished our 4-hour run. We're going to turn off the electrical current, and we're going to move our gel to our viewing station. As you can see, our dye is about halfway down to 3/4 of the way down your gel. And to view this, we're going to use a blue light transilluminator to view the cyber green, the cyber safe dye which is in it. So we have our gel here. This blue surface behind you, behind the image, is the transilluminator. I'm going to gently roll my gel off of our gel casting tray and directly onto the transilluminator. And now I'm going to turn off the lights and turn on the transilluminator. What we have here is our gel viewed under the transilluminator, and you can see our DNA is the bright bands, and you can see the bulk of our DNA is right here in this region, and the shear goes all the way down to the smaller sizes. This very small band down here is our leftover circularization adapters. If you do not see this band during your 8 KB and 8 KB gel only, it means that you forgot to add the circularization adapters and you should not continue. This is a good QC, but is only, again, I'm going to state this, for the 8 KB gel. The 1 KB plus extend ladder is located to the left and right of our bulk of the DNA. And I'm going to list off the sizes as we go down. At the very top, we have 40 KB, then 20 KB, 15 KB, 10 KB, 8 KB, 7 KB, 6 KB, and 5 KB. For the 8 KB protocol, the bulk of our DNA lies between the 10 KB marker and the 5 KB marker. So what I'm bringing to the gel now is a ruler that we've covered with some autoclave tape so that it fluoresces a little bit, and I'm going to show you how to use this ruler to cut out the appropriately sized gel cut for the 8 KB protocol. In general, you want to cut the bulk of the DNA, and by bulk of the DNA I'm talking about this bright band right here. If this were located at any other region other than 8 KB, this is what you want to extract. In general, for the 8 KB that shears properly, you're going to want to cut a little bit below the 10 KB and a little bit above the 5 kb. In general, those are the ranges that I use. So let me just cut this. I'm going to use the ruler as my marker, and I'm going to cut using a scalpel just where the DNA is and not where the ladder is. And then we'll cut just above the 5 kb. And by using both sides of the ladder, we're able to get a very accurate gel cut. I'm then going to cut to either side of the DNA band. I'm then going to extract my band by making a single incision out to the side of the gel. You can now remove our gel band, and we can do this by gently prying open the cut that we made in the side and pushing out our DNA band. If it doesn't come readily, it means we haven't cut all the way through the gel, which you can just quickly cut again and try to release it. Now you can see our DNA band located to the side and the region where we cut. And in this example, we've excised the majority of the DNA band and located it to a singular location while leaving the sizes that we unfortunately cannot use. Alright, so we're going to remove our filter. We have our isolated gel slice. In the lab we use aluminum foil to temporarily hold and slice the gel slice. It's pretty useful. We're just going to slide that gel slice off and onto the aluminum foil, and then we're going to slice this gel slice into 3 roughly equal sized pieces for stacking into the Elliott trap. Alright, we have 3 roughly equal sized pieces. Now before we proceed, we have to assemble the Elliott trap.